Hello guys, welcome once again to Academic Solution. Physical Science class grade 10 with me, Martin Otin Ado. Please, one thing that you should always note that in this video, the reference book that was used to compile this video is the Level Up by Academic Solution. The Level Up book is simplified and is very interactive. It contains past questions and memos. It has been simplified for you. So quickly make a point with us to get our Level Up book. Now, in this video, we will be focusing on talking about what we call as charge quantization. The word quantization may seem new to you, but after today, we are going to see what it means. But before we come to quantization, let's quickly remind ourselves on our previous studies on electrostatics. I believe you still remember we said that charges are not created and at the same time they are not destroyed, but they are conserved. That is what we established on principle of conservation of charges. We also got to know how a body becomes a positively charged, a negatively charged, and when do we say a body is a neutrally charged. Today, our video will basically be on what we call as charge quantization. Now, when we say a charge has been quantized, simply put, quantization simply means that we want something to take a specific value. And what is this something that we are talking about? We are talking about all charges in the universe to be able to take up a specific value. So what it implies is that the charge must assume a discrete value. That is to say that when we observe the value of a charge of a particle, it might be the integral multiple of 1.6 times 10 to the power of negative 19. That is the charge on every electron that are in the universe. Quickly, let's look at what the principle of quantization states. It states that the principle of quantization states that every charge in the universe must be the multiple of a charge on one electron. So once we know that all the charges are associated with a one-hole electron, so all charges must be a multiple of what? Of one electron, which we call as what? The elementary charge. This elementary charge is being expressed as 1.6 times 10 to the power what? 19 coulombs. So if we want to express a charge, we say that the charge is given as this, right? A charge can be expressed as is equal to the number of electrons times the what? The elementary charge. That comes to the fact that we said every charge in the universe must be a multiple of the charge of one electron. So the one electron charge is this one, and if this is our number of electrons, then this becomes my elementary charge. We are going to be using this in finding out and doing some calculation, but remember we said the elementary charge is always 1.6 times 10 to the power 19. Let's quickly go and look at the application of quantization of charges. First question on the application of quantization of charges. It says an object has an XX charge of negative 1.92 times 10 to the power 17, negative 17 coulombs. How many XX electrons are there? So just like we've been doing, anytime you have a problem, you must first of all analyze the problem and identify which principle you are to use. So let's analyze this problem here and see what is the problem, and we will go on to look at which principle are we going to use. Now, we have been asked to determine the number of electrons based on the total charge. We know that charge is quantized and that electrons carry the base unit of charge, which is negative 1.6 times 10 to the power 10, negative 1.6 times 10 to the power 19 coulombs. This is the elementary charge that we spoke about. So this is our elementary charge that we said every charge in the universe is based on this elementary charge. It's a multiple of this elementary charge. So let's go and apply the principle. Now, as electrons carry the same charge on the total charge carried must be made up of to a certain number of what? Electrons. To determine how many electrons, we divide the total charge by the charge on a single electron. So it's all coming from the what? Our charge, which is equal to the number of electrons, okay, the number of electrons multiplying the what? The fundamental or the elementary what? Charge that what we know. So simply put, what we can simply do from here is just a change of subject, whereby we've been given the what? The charge which is here, and then we also know the what? The elementary what? Charge, which is what? 1.6 times 10 to the power 10 to the power 10 to negative 19 coulombs. So what we simply do is that if we want to get it, we will say then my number of electrons is simply equal to what? The charge which has been given divided by what? The elementary charge on all electrons, in which all charges on the universe becomes a multiple or integral multiple of. So we just take this charge and then we divide by this one, and quickly it gives us the number of electrons that we have. Let's take a next example. It reads, a glass rod is positively charged by rubbing it with a silk. The charge on the rod is 1.12 times 10 to the power negative 11 coulombs. Calculate the number of electrons that were rubbed off the glass rod. So in this question, firstly, just like we did, let's try to identify what has been given, then we will go on to apply which method or which concept that we are going to use in solving the problem. We have been given the charge on the rod as what? 1.12 times 10 to the power negative 11 coulombs. Then we need to find the number of electrons rubbed off the glass what? Rod. Simply put, when it came into contact, there was some transfer of electrons from the what? From the glass rod. So that is what we need to what? We need to identify. Step 2, let's identify the concept or the method. We can use the concept of what? Charge quantization to find the number of electrons which was rubbed off. And what are we going to use? We already, just like I indicated in the first example that we saw, we already saw that charge, okay, is equal to what? The number of electrons multiplying the what? The charge in what? Of the unit of the elementary charge. So if we want to find the number of charge, we just divide both sides by the what? By the elementary charge. Here we divide both sides by the elementary charge, which gives us what? The number of electrons, and that is what has been illustrated here. The charge is equal to this, just like I've indicated here, and then the n, which is the number of electrons that we need to know, is equal to this. We have already been given this. We know this is a what? This is what is a constant that we use. So by using this one, we just divide both of them, and it gives us an answer of this one. quickly, let's take another one, which I'm going to give it to you as a homework, and I'll provide the solutions in my next videos. It reads, two identical metal spheres are different charges. Sphere 1 has a charge of negative 9,6 times 10 to the power 18 coulombs. Sphere 2 has an XX30 electrons. If the two spheres are brought in contact and then separated, what charge will each have? How many electrons does this concept correspond? So before, let me start to give you a clue on how to tackle a questions like this. First of all, let's analyze what has been given. We are given there are two identical sphere metals, okay, and then they say they have different charges in them. One of them have a charge of negative 9,6 times 10 to the power 18 coulombs. Then the sphere 2 has 30 XX electrons. If the two spheres are brought into contact, then they are separated again. What charge will each one have? So here we are going to be using the principle of of quantization, as well as the principle of conservation of charges. So what you will do is, we already know that first of all we know the number of electrons. 30 excess electrons have been here. We know the elementary charge. Here is a charge on one of them, the charge on the other one is unknown. So we need to know the charge on the other one. And how do we know the charge on the other one? We can get to know the charge on the other one by simply using the principle of quantization of charges, okay? That we say that every charge is a multiple of the elementary charges. So what it simply means that we are going to be multiplying 30. We multiply 30 times the multiple charge that we know of, okay, times 10 to the power 10 negative negative 19. That is what we will be doing. So from here it will give us our charge that we know of. Once we know our charge, then we go back to use the principle of conservation of charges, which we saw that when two charges are brought together, because over here they are telling us that the charges were brought together into contact, okay, and they are metal spheres. So it means that there is going to be a flow of electrons, the negatively charged electrons, from one point to the other metal, up until all of them are have the same number of electrons that are there. So we will come back to use our charge on each of them, which is it gives us charge 1 plus the charge on the other one, which is charge 2, all of them divided by by 2. So we will put your answer here as the initial charge for the second sphere, and from there you will be able to get your answer for it. So I leave this up onto you. Just go, you do your calculations, and then you will be able to get the charges that we are looking for. Then from there we can take number 1, number 2, number 3, number 4. We're talking about the two types of charges that you have, what provide an evidence for the existence of the type of charges. Then you should be able to take up until I will provide the full solution, the full answer, and then you'll be able to check yourself how you are doing when it comes to electrostatics. Until then, please keep on sharing the video. It is Physical Science Grade 10 with me, Martin Otin Ado. Don't forget to come to Academic Solution, contact Academic Solution for our book on Level Up Physical Sciences Grade 10. Up until we meet again, please share the video. Bye bye.